Here's a really simple example using Jupyter Notebook. I've started Jupyter Notebook and I wind up with this browser window with the notebook running in it, and I've got the opportunity now to either open some existing notebooks or start a new notebook. So I'll choose New and Python root. That'll get me a notebook that allows me to write some Python code. Now, first thing we should know about writing Python code, I can put in comments with the hashtag symbol. And so this is a comment, and it does nothing. So now that I've created this one little cell here with a comment in it, I could run that cell by pressing the play button here. It's going to run just that cell, and it'll move down to the next cell. So I pressed it, it ran it, it did nothing. So I'm going to add some more things to this cell here. First, I'm going to put this directive in here that says matplotlib inline. And that means that, that means that when I run the matplotlib library, it's going to display any graphs that it draws right in the browser window for us. Well, if I wanted to draw some graphs, then I'd better import the matplotlib library. So I'm going to import part of it. And the part I want is the matplotlib library, the particular part called a Python plot. And I'm going to import that just as PLT, short for plot, because I don't want to have to type out pyplot every time. And I'm also going to import some numerical stuff. I'll import the NumPy library. That's a whole lot of numerical things in Python. And I'll import that as NP, just as a short form that I can refer to it as. So now I can run this whole cell again and see what happens. And it doesn't look like anything happened, but I hope it's done the things I told it to. It's imported some stuff so that now we can do some things with it. And I want to make some data, some arrays of data. So I'm going to say that the count that I'm going to use for my arrays is 4. So I'm going to start off with just 4 things so it's easy to see what's going on. And I'll set time t equal to, and here's where I'm using this NumPy library. It has a function called linspace that creates an array of linear values between 2 limiting values. So if I do linspace of 0 and 1, and I say that I want count things of it, then I hope I'm going to get an array with 4 items in it that runs between values of 0 and 1. So let's have a look at what happens. Nothing happened. I need to actually print it out. Now, just putting in the name of a variable is sort of short form for show me what's in the variable. So here I got 4 numbers, 0, 0.333, 0.6667, and 1. 4 values evenly spaced between 0 and 1. So that's good. And if I wanted to plot some numbers against time, how they're varying, let's say it was temperatures, I could make it a constant, or I could make it randomly varying. So I'm going to set t equal to, I'm going to use another NumPy function. It's part of the random library in NumPy, and there's one called rand, and that'll give me ordinarily distributed, evenly distributed random numbers. Or I'm going to use rand n, which is going to give me normally distributed random numbers. Numbers that peak towards 0 and are less and less likely to occur the farther we are away from 0. And I'll create a similar sized array of those. So if I run that one. I could look and see what's in T. And it looks like I got some fairly random values there. And now let's plot on the x-axis, T on the y-axis, and see what we get. Whoops, I didn't get what I wanted. I need to remember that I'm trying to get this from the matplotlib library, this pyplot thing. So I have to remember that I called it PLT plot. Let's try it again. And there we go. 4 numbers plotted with lines in between them. That's not very exciting. I could do that with graph paper. But let's try making this 400 numbers instead of just 4 numbers. I'm not going to print them all out because that would be huge. But I'll go down here and pick this cell. I'll make another 400 random numbers. I'm not going to print them out either. And then I'll plot them. And here's 400 random numbers. They're Gaussian distributed. They're much more likely to be close to 0 than they are to be really far away from 0. And that looks like a really noisy analog signal measured from some device. Now, the temperature isn't really going to be always around 0, so let's make T equal to some average temperature, let's say 20 degrees Celsius, plus some random noise that we're getting. Looks like it's going about plus or minus 1 degree typically, and sometimes as much as plus or minus 2 degrees. So I'm going to regenerate and run the plot again. And now my mean is 20. My standard deviation is plus or minus 1. And 95% of the time, I'm within plus or minus 2 standard deviations. Let's try it with 4,000 samples. And each time I'm going to a particular cell and I'm pushing the play button to execute that cell. And here we've got a whole lot more samples. So we can collect data like this or play with data like this using Python. So you try.